Hey friends, welcome to today's training video. Now I am going to do more of a POV style just because it's easier for me when it comes to recording. I don't have to move the tripod and it's just easier for me overall to be able to produce more videos for you guys. Today we're going to be talking about a heat pump on heating mode for a split system. Now have in mind this is an inverter, but the principles that we're going to go over today still apply for a typical conventional heat pump split system. And a lot of people have a hard time understanding heat pump heating mode on a split system because on a typical package unit, you only have two service ports. On a split system, heat pump, you have, you see, 1, 2, 3. You got those 3 ports. So that third port confuses a lot of guys, but I hope that by the end of today's video, you have a good grasp of how to use that port when we're in heating mode for a heat pump. Now, it is important to understand how a heat pump works. We're not gonna go too deep into it. I do have a video on heat pump. I have had people tell me if I can do a lecture on it, and sure, I'll do that in the future, but let's go over real quick over this poster here, and credit to the one that made these posters. I'm sure you already know, and amazing posters. Really tell you all there is to a heat pump. Now, this is a split system, a mini split, a split system, but the principles are still the same. So in cooling mode, right, nothing changes, right? Condenser, evaporator, compressor, and metering device. In cooling mode, and you have a reversing valve, it sends that high pressure, high temperature vapor to your outdoor coil first. So your outdoor coil is your condenser. It turns to subcooled liquid, and then it goes through a metering device. You get saturated refrigerant, and then you have warm air coming inside your house, boiling off all that saturated refrigerant. Then you get superheated vapor coming back to your compressor. For heating, it's the same, but it's just in reverse. So it just depends on the reversing valve. And this is what we're going to go over. Does the unit default in cooling or does it default in heating? So we'll go over that in a bit. But in heating mode, everything stays the same. But the compressor will push that high pressure, high temperature vapor to my indoor coil. So my indoor coil is my condenser. Same thing, high pressure, high temperature vapor. You have cold air coming in because the house is cold. Then you have hot air coming out. You're rejecting heat, hot air to your house. You have subcooled liquid coming back, going through the metering device, saturated refrigerant to your outdoor coil, which is your evaporator. And hopefully, if it's kind of not too cold, you have some superheated vapor that goes back to through your accumulator and to your compressor. But that's the idea with a heat pump. So focusing on heat pump split system heating mode, and this is kind of decided to draw it out a little bit more bigger so you can see it. This is going to be important. The numbers right here, right? And we're going to go over that right now. But this is in heating mode right now. How do we know? Because it's sending that high pressure, high temperature vapor to my indoor coil because I want to heat the indoor. I want to have hot air going to my supply vents. And then it goes to the metering device, and then it goes through my evaporator and the same process. But what's important to understand is the reversing valve, okay? So the reason why the split system has 3 ports is for this reason. And the ports, you'll find them right here. One, it's gonna be on your hot gas line. Well, it depends, right? If it's heating or cooling. So let's just talk about cooling. So we try to differentiate, okay? Right before we go to heating. In cooling, right? And you see the difference right here on this reversing valve, the U, this right here is cold. And on this side, you have the high pressure, high temperature vapor coming to the right. So the top will never change, okay? On a reversing valve, that will always be your discharge line. This will always be your true suction line. That does not change. What changes is if the high pressure, high temperature vapor is gonna go to the right or to the left. So in that case, it's going to the right. On this case, it's going to the left. So going back to a split system, okay, in cooling mode, my high pressure, high temperature vapor is gonna go this way. And of course, when it goes this way, it goes to my outdoor coil. So if it's going this way, this side is going to be connected, right? It's either going to be, this side's going to be connected, and then the high pressure, high temperature vapor is going to go that side, or it's going to be high pressure, high temperature vapor going to the right side, and these are going to be connected. My number 3, I want you to see that, my number 3 and my number 3, that does not change, okay? So my number 3 right there, and number 3, in this case right here, we're calling it the true suction port for my low side pressure. True suction port. So where's number 3? So that's number 3. That's what we're calling it for now. That's my true suction port. Now, right now, I currently have the system in cooling mode, okay? You can tell right there, it says C1. So it's in cooling mode, okay? And we'll go over all the wiring right now as well. But right now, if you look, think about your typical cooling only conventional split system, right? You have your high side pressure connected on your liquid line port, right? And then your low side, right? Your low side goes on the bigger line, right? The suction line. So this is good. It's working. It's in cooling mode, low side, high side, okay? Now, can I connect this one here, this one to my true suction port? Sure, why not? They're both suction. It doesn't matter. So I can connect that one there if I wanted to, because when you go back, right? When it's in cooling mode, you see, that is my true suction port. And then when it's in cooling mode, this number 1 right here, right? Number 1, suction line port, that number 1 is this one right there, okay? So I think we pretty much have this, we pretty much understand this because most of you guys work on a typical conventional cooling only mode split system. The small line is the high side pressure, the big line is the low side pressure. And on a heat pump with the split system, it doesn't matter if you connect it right there, because that's your true suction port, or right here. But it's better just to connect it on the big one. You can put your temperature clamp to get your superheat. Okay, so that's for cooling. For heating, the reversing valve shifts, and it's going to be important when it defaults to heating, when it defaults to cooling. We'll go over that right now in a bit. But the idea is for heating, remember where number 1 was at? On cooling, number 1 was my suction line. For heating, because now we're sending the high pressure, high temperature vapor this way, look at number 1 right now. My number 1 is going to be hot because you have the high pressure, high temperature vapor going this way now. Okay? So I'm going to do a little demonstration right now, okay? So, and you're going to see what's going to happen. So look at my pressures right now. Let's go ahead and turn it on. So now, right now we're in cooling mode. Everything's connected correctly. Let's see if the light probably does not help as much. So let me go and turn it off. Right? This blue one, the low side of my suction line, right there. That makes sense. Low suction pressure, lower. My head pressure is over here on my liquid line, okay? So look what I'm gonna do when I call for heating. Look what's gonna happen. So I am gonna use alligator clips. So we'll go over the wiring, but this system specifically, it defaults to cooling. You have to energize the reversing valve to get heating. So what I'm gonna do right now, I have a jumper for cooling. So right now, all I have is R. I am bypassing the thermostat, but I do have R and Y touching each other. That's all I'm doing. I'm calling for cooling. So R and Y, I put a jumper, it's cooling. If I want heating, all I have to do, and I'll go over the letters right now, I have to send 24 volts to my B terminal. Look at that, my B terminal, you see B. Okay, and so we'll go over that right now, what that means, but I'm gonna go ahead, what I do, I go ahead and get 24 volts from this alligator clip, okay? And I don't want that falling, so I'm gonna make sure that and sure enough, it did fall. You see the little fault? So let me go ahead and see if I can do this, and then I'll show you what I do right now. So let's go ahead and, okay, went back to C1, you see that? Okay, and then let's go ahead and power up, right? I'm just getting 24 volts and going to B. Okay, so right now, I have 24 volts going to Y and to B, okay? So now, because the alligator clip did disconnect, and because it's an inverter, they're very special units. They take a little bit to turn on. So that's okay. We'll just wait for it to turn on again. Okay. And I'm gonna show you right now what's gonna happen when I call for heating. So you saw earlier, right? I haven't moved anything. My hose here is still on the suction line. My high side is still on the liquid line. I'm gonna call for heating. And so when I was in cooling right now, that one was low, that one was high. So once it heats, I want you to pay attention to that right now. So we'll have the unit turn on right now. So, but kind of going back to this, in cooling mode, okay, in cooling mode, right, going back to the numbers, right, so right here. So the one thing that's going to be easy for us to understand is number 2, right, liquid line port for heating, right, that never changed because my liquid line is the liquid line. The only thing that changes about the liquid line is the flow of the direction. So when I'm heating, it's going this way. When I'm cooling, the subcooled liquid is going that way. And of course, we have our 2 metering devices there as well, right? One, when it's heating, it's flowing this way, right? Because if it's coming down, it flows. And then on this metering device, if it goes up, it meters. And same thing, right? When I'm cooling, if it's going that way down, it flows. And if it's going this way up, it meters, okay, to my evaporator coil. But we're talking about heating, okay? So my number 2 does not change. My liquid line port remains the liquid line port. And also too, number 3 doesn't change, okay? My true suction port, right? So number 2 did not change. Number 3, because this is your true suction port, does not change. Where it confuses a lot of guys is number 1, okay? Because number 1, the big suction line that goes into your compressor, that's your suction line. But when I'm in heating mode, okay, I repeat, when I'm in heating mode, number 1 turns to my hot gas line. It's a high side pressure. It's a high pressure. Number 1 suction line converts into hot gas line. So right now when the system turns on, we'll go over the pressures right now. But that's where it confuses a lot of people because when I'm in cooling mode, right, as you can see right here, cooling mode, this one, my true suction and the one on the right, they're both cold, low side pressure. When I'm in heating mode, the port hasn't changed. That's still number 1. Over here, it's still number 1, right? You still see that port that's over there on your right side, right? It's still there. That hasn't changed. But the flow of the refrigerant has changed. So in heating, number 1 now becomes high side pressure. It's my discharge line. My high pressure, high temperature vapor going to my indoor coil. So that's the big difference when it comes to heating, okay? Number 2, 3, right? That one, my liquid line port and my true suction, they stay the same. But what changes is number 1. So we actually have to, if you're gonna connect our gate right now when it turns on, we're gonna have to move that one over here to read our true suction because this one's gonna be high side pressure. That's also gonna be high side pressure. So we're gonna have to actually move this one here over here to read our true suction, okay? Now, it is important to understand this, right? Because like I said, inverters, you just gotta be a little patient. I'll show you a little pro tip when it comes to the reversing valve right now too, but this reversing valve here, which is this one here, the 2 blue wires, and you can confirm it by looking at the schematic here, just to kind of show you before I forget this point. My reversing valve, you see, 1, you see right there, so 1, 2, 3, reversing valve down there, right? So when I call for heating, you're gonna see the voltage that a reversing valve takes in heating mode. It's no longer 24 volts, it's high voltage. And I've noticed on mini splits, they take about 208 to 220 VAC, volts alternating current, to make that switch. So it's a bit different than this package unit that has 24 volts going to the reversing valve. So it is a bit different, but it's the same concept as well. Okay, so we're still gonna let it turn on. It does take a couple of minutes, but the one thing that I did wanna go over is this right here. When it comes to the wiring, okay, the wiring does not have to be hard. And a lot of people have a hard time sometimes wiring up your, when it comes to heat pumps, right? So typically what you have is this right here. Let's say, before we go up here, let's say you have your outdoor unit, right? all you're needing your T-stat and then your indoor unit. So you're supposed to run, so right here, your T-stat, right? So, and actually it's probably gonna make more sense if I put a T-stat over here and indoor unit over here, okay? So for my T-stat to my indoor unit, you're gonna run 5 wires, okay? Right, as we know, it's gonna be 18 gauge, right? 5 wires. For my outdoor unit to my indoor unit, some contractors have it's a good tip. They run more wires than what they have to, because what if they crush 2 wires? At least you have extra wires. But technically all you need, and it depends on the system, but you need one for your compressor, one for your reversing valve, and I just heard it turn on, so that's good. It's gonna help us right now, so perfect. So we'll let it do its thing right now. Just heard it turn on. But what you got going on from your T-stat to your indoor unit, your outdoor unit to your indoor unit, one for Y, one for O. Sometimes they do ask for R and C. So this is what we got going on. So let's go ahead and put my 24. So my indoor unit has the transformer, right? It's got the transformer. My T-stat is just a switch, right? It's just a switch, okay? Just a switch. So we got R, C, G, and then RCG, Y, and then OB, okay? So over here too, OB, Y, C, and R, okay. So when you're running wires, typically you're gonna run 5 wires from your thermostat to your indoor unit, and then from your indoor unit to your outdoor unit, you're running 4 wires. This is what confuses some people here, and at least for me it did initially. Your thermostat, for your G, just your G just makes it to your indoor unit and it stops there, period. It does not go to your outdoor unit. But the rest of the wires, R, C, power, because it's getting it from your indoor unit, they all go wire nutted. So you got it from the indoor unit, you're feeding 24 volts to my thermostat and to your outdoor unit at times. And then also, you have to run 2 other, you have 5 wires, you have to run for your compressor, your Y, and your OB. So yes, the wires right here, right? This specifically, these 2 right here. These right here, you can run them home run all the way, because Y and OB don't have to land right here to my indoor unit. Your thermostat's a switch, so it's gonna send 24 volts to your compressor and your reversing valve. But most people just wire nut them here because it's just easier, so you wire nut them as there. So you got 5 wires, right, from your thermostat to your indoor unit, and then from your indoor unit to your outdoor unit, you got 4. Your G just makes it to your indoor unit for your blower motor. I'm done. My 24 volts comes from my indoor unit, powers up the thermostat, okay, RC, and it also sends, you also send power to your outdoor unit's board. My Y and my compressor and my reversing valve, these are not coming from my indoor unit. It's not. It's coming from my thermostat, because that's the switch. So 24, when I have a call for cooling or heating, it sends it, because the thermostat is just a big switch, to my actions. And then that one goes all the way to my outdoor unit. But of course, you can wire nut them here. So 4 wires here, 5 wires here. Okay, so we finally have heating going on. I didn't want you guys to wait. So before we go and do what we have to do down there, right? Because you're gonna see that something's off. It's important to understand this part here. So certain units, so for example, Rudd, Rheem, and Bard, the unit defaults to cooling, right? So typically, when you go to a system like this package unit, right? This package unit, this right here, and I'm sure you worked on this carrier, these smaller package units. When the R, and there's no power right now, right? But when your 24 volts goes to your yellow wire and your reversing valve, you get cooling, right? So this unit, it defaults to heating. And if we're on cooling, I need to send 24 volts to my reversing valve. But here we're saying that there's certain brands, right? There's certain brands where it defaults to cooling. You actually have to energize the reversing valve. So for Rudd, Rheem, and Bard, and for this specific Bosch inverter split system, it defaults to cooling. So if something happens to the reversing valve, it breaks or something happens, you will always have cooling. So that's pretty nice on a city where it gets really hot. You don't have to fix the problem because it's gonna default to cooling. But in the winter, it won't work because your reversing valve went bad. If you want heating, you're still gonna power up your Y, but then you're gonna power up your B. So a lot of people have a hard time understanding the OB. All that means is that if you have a system and you have to read the manual to confirm, but most of these brands here, they work like this, where if you send 24 volts to your reversing valve, you get heating. It is a B action, B action. And we'll go over this right now. So if it's a system where you need to energize the reversing valve to get heating, you're gonna have to send power to your B terminal for heating. So right now I have thermostat wire going all the way here, and then I also have wire going from here all the way to my outdoor unit. So this is what I was saying. When you have to run wires, you can also run the wire on the terminal strip right there, right? You see, you can just run them there and put two wires on the same place. Sometimes you can, sometimes you have to wire nut it, but in this specific case, you can. So right here, I got wires coming here and then wires going here. So you see, when you get closer, and I'm gonna confirm, because this wire, you see, this one does not take your power. It just takes a common, right? A common, the B and the Y. And there is a W, but we don't have to go over that today, but it's common, B and Y. So I'm gonna confirm, and you're gonna see that it is getting 24 volts here. So I'm gonna go ahead and just check my common. We're using black for common, okay? Okay, so we're gonna check the B, okay? So right here, I got the B right here, okay? I'm checking common and B. Okay. 24 volts. And of course, we need Y as well, and I'm gonna go ahead and confirm. Okay, I'm checking with Y, right? I'm still checking common with Y. Okay, so I just confirm between common and B, common and Y, that I am sending 24 volts, and I'm in heating mode right now, okay? So I can feel the cold air coming out, because this is my evaporator. So I'm in heating mode. And just a little tip, I know I was gonna mention this, I was gonna show you this later, but this is my reversing valve, those two blue wires there. This is not a 24 volt reversing valve. This is actually high voltage. So let me see if I can show you here the voltage in the back. Give me 1 second. I'm using my little leads, right? It's important to use the little leads. And look at that. The reversing valve, I'm sending 208 volts. VAC, not DC, VAC. So sometimes on these mini splits inverters, you're sending high voltage, right? But you know that I'm energizing I'm in heating mode. I'm energizing the reversing valve, and I can feel that it's cold, and I have hot air coming out, right? But so it's important to understand what kind of brand you're working on, because most systems, most other brands, you have to energize the Y, and you get heating. If you want cooling, you need to energize the Y and the reversing valve. But because this one defaults to heating, and you have to send 24 volts to your reversing valve to get cooling, this is an O action, okay? So to power up, to get cooling, and if you need to power up the reversing valve, it's O. If it's heating and you need to power up the reversing valve to get heating, it's a B action. So that's gonna be important when you program the thermostat, which I'll show you right now. But I want you to see one thing right now. Look at that. Right now, I am reading 247 PSI, 248, 247. You're reading the same pressure. You're like, why is that happening? It's the same pressure. What's going on? Well, remember what we said, because this line right here, and I can feel it, it's hot. This line, we just said, this is coming from my discharge line, my high pressure, high temperature vapor. So yes, even though it's thick, it's still going this way. It's still my discharge line, my high pressure, high temperature vapor, going to my indoor coil, which is my condenser. Then it comes back this way on my liquid line, coming down. And that is why we have a bidirectional filter dryer, right? And then it goes inside, right? We just said in cooling, right? This is gonna be cold, but in heating, now it's going that way. So what do I have to do? Well, check it out right here. So obviously that's something's going on because that's high right there. So you typically can leave this one right here because this is my high side. That doesn't change. But this one here, you got to move this one to my true suction over here. You see the port over here? You can see it right there. Okay? So I'm going to go ahead and close this off and then connect it over here. Okay? All right. I'm going to go ahead and connect that on this port here. Okay? All right. Look at that. That's much better. So now I'm in heating mode, 261 PSI, and then 67 PSI, right? 67 PSI for my my low side, and it's a 454B refrigerant. But you see now they're no longer equal because this is reading the true suction. So just to emphasize a point, split system, heating mode. This one's my high side. For cooling and heating, this one stays here. For heating mode, you gotta move the hose from here to my true suction port. Because for heating on a split system, you have to move it here because this one becomes my high side, my head pressure, like this one too, because this one's going to my indoor coil because I'm in heating mode. So you gotta move the hose from here to read the true suction, which I am right now, right? Now I think we're good to go. Now, none of this would matter if you don't do this, okay? None of this would matter if you don't do this. You have to go to the thermostat. So system, so actually let's go to, we gotta go to installer option. We gotta put in the code. On this one, it's 1849. Okay, and then, oops, down, okay, done. Okay, look at this right here. You have to program the thermostat. So when it talks about right here, back, right here, heating system. I want you to see this. Heat pump, next. Okay, air to air heat pump. It's not water, right? I think it's gonna give us geothermal, but nope, it's air to air. Okay, this is where it's important. You have to put this right. So obviously this thermostat is for this unit. It's not for that one. So, but we don't have, this one technically has to be on that unit there, but just kind of trying to bring up a point when it comes to the thermostat. If you don't program this right, it'll never work correctly. So you have to find out if it defaults to cooling or to heating. So if you don't know, you can simply power your R and your Y and see if it's cooling or see if it's heating or read the manual. On this one, we know that it defaults to cooling. We need to energize the B, the reversing valve, to get heating. So it's a B action, B as in boy. So right here, you see, when you get closer to here, look what it says right here. Give it a second. Okay, right there. You see, OB on cool. We don't need that one. That doesn't apply for this Bosch system because we just said we need to power up the reversing valve to get heating. So it would be that one right there. B, you see the first letter right there? B, OB on heat. And then you would push done and then save the settings. So thermostat has to be programmed right. You have to program right. Another thing is running the wires, right? We just said right here we got our thermostats back there. So R, C, Y, your reversing valve, and your G, right? So your G goes straight right there for your blower motor. So pretend it's just a fan coil heat pump, right? Your G goes for your blower motor, and then your R, C, Y, and reversing valve, they go into the actual terminal, right? Terminal board there. But then from here, you still have to run 4 wires. So certain outdoor units that are heat pumps require a power and a common. This one doesn't. But let's just say it did. You have to run 4 wires. So you bring 4 wires from here, and you can put them on the same slot. Your red, right? Your red goes to your red for 24 volts. Your common to your common. And then your Y, right? Your yellow, your Y goes from here to here for your compressor. And then your reversing valve from here to here. The tricky part is that On this specific unit, they do want you to put it on the actual terminal board here. But whenever you've dealt with this typical fan coil split system heat pump, you do not have to land the Y and the reversing valve to the board. You just wire nut it and it continues all the way outside. So I'll repeat that again for your Y and your OB. You go, the two wires that come here, you just wire nut it with the Y and the OB that come from your thermostat, wire nut them. You don't have to connect them to the board. Now this is an inverter board. They do ask you for you to put it right there. They're a little bit more complex, but your typical split system fan coil heat pump, you do not have to do that. It's a lot easier. But you do have to run 5 wires, and then you still have to run 4 wires. And your thermostat is the big switch, right? That controls basically if it sends 24 volts to your G for your fan, 24 volts to your compressor, or to the reversing valve. It does not land on your board here, but on this specific one, it does. And on that package unit that we have over there, on your thermostat, we would have to put cooling on O, right? Not on B. So that's the idea with a heat pump. Understand that on your split system, does it default to cooling or heating? And if I energize the reversing valve, am I heating or am I cooling? And if I am heating, when I energize the reversing valve, then it's a B action. You gotta make sure you put that on the thermostat. If you have to energize the reversing valve to get cooling, then it's an O action, right? They still both have reversing valves. It's just that one, you energize, you get cooling, O. One, you energize, and you get heating, that's B, okay? And then for heating mode, remember to move this one from here to reach your true suction. And honestly, if you were to call for cooling right now, you can leave this one here because it's already on my suction. It's my true suction, right? So understanding how the heat pump works, that will help out a lot. And then just understanding what kind of brands you're working on. And that at the end of the day, all you're doing is, for these systems, all you're doing is just powering up 2 actions to get heating. On this one, RYB, right? On this one, for systems that default to heating and to power up to get cooling, you're just powering up 2 actions, Y and O. But your B and your O, remember, it's still a reversing valve, but in your thermostat, that's gonna be important to program it correctly. So whenever you find yourself on a split system, hopefully it's not an inverter, but just a typical heat pump, just find out what it defaults to first, right? What kind of brand is it? Programming the thermostat, making sure all the wires are correctly wired from your thermostat to your indoor unit and then to your outdoor unit. Make sure that everything's wired correctly. Understanding how heat pumps work also helps out a lot. And typically for a typical conventional split system heat pump, the reversing valve is going to be getting 24 volts. On these mini splits and inverters, they get about 218, 220 volts. It's high voltage, but the board does that for you. You don't have to jumper anything. On the ones that you work on conventional systems, you could jumper it, and then you can see if it defaults to, if it energizes, if you get heating when the reversing valve energizes, or if you get cooling when the reversing valve energizes. And this is my little setup right here. It took me a bit to try to get something that would work, but the idea is that if I can record on POV, it's gonna be a lot easier for me to record, to post more videos. And please give me your honest opinion. There's gonna be times where I am gonna give a lecture and I'm gonna go with the tripod, but this just works out better for me so I can continue producing more and more videos. I hope that today's video helped you out, and I'll catch you on the next one.